Hello, thank you all for joining today to listen to my talk entitled Executive Functions Relate to Emotional Reactivity in Detection Dogs, which was the last chapter of my dissertation. I want to start really broadly and talk about canine cognition and what the science is today. So there's something known as the rise of the dogs, which really is about the dramatic increase in research devoted to canine cognition that has occurred over the last 2 decades. This graph really sums it up nicely. You can see the dramatic increase in the number of papers per year devoted to dogs that started in about 2005. And in this graph, you can see the number of countries that are collaborating to learn more about what makes dogs dogs. Just to give you a little background on the study topic, canine cognition and the research involved with it has been pretty unbalanced, with the majority focused on social cognition, which came about due to the debate of whether dogs' unique social roles were due to genetic changes, or phylogeny, versus social pressures, or ontogeny. And little focus was given to non-social cognition, in this case, executive functions. In fact, as of 2016, only 14 papers implemented short cognitive tasks to evaluate executive functions in dogs. Of these 14, 13 were in pets and 1 was in free-ranging animals. However, this is changing due to a couple of different reasons. First, there is evidence that aging dogs show the same morphological and cognitive deficits as aging humans. So this has value in both veterinary medicine as well as human medicine. And second, there is an increase in evidence that executive functions may relate to working dog suitability. Before getting into the current study, I want to give a few definitions. So first, executive functions can be defined as top-down mental processes that require the effortful use of skills such as working memory and inhibitory control. Within executive functions, you have working memory, which in non-humans can be defined as short-term memory for stimuli within a given experimental trial or session. And second, you have inhibitory control. Now within dogs, this has been broken down into 2 sort of types. The first one being cognitive, which is your typical delay gratification. So you have 2 options, but you need to either expel more energy or wait a longer time for the better option. And you also have motoric, in which you have 1 option, but you need to inhibit a costly choice for a more advantageous one. Now together, these processes allow for cognitive flexibility, or the ability to take goal-directed action in response to changing stimuli and environments, instead of just innate automatic reactions. The purpose of the current study was twofold. First, I wanted to assess the construct validity of common tasks proposed to assess executive functions in dogs. So I did this by giving dogs a newly created spatial discounting test, which is purported to assess inhibitory control, and also a visible displacement task, which is commonly used to assess working memory in dogs. The idea was to relate these tasks to each other to see if they loaded on to a central executive function component. The second goal was to determine if performance on either of these tasks related to detection dog suitability. Now, detection dog suitability can be broken down into 2 different facets. The first one being performance, which encompasses all the characteristics related to successful search behavior, such as motivation to hunt for targets for extended periods of time, and environmental soundness, which is often measured in terms of emotional reactivity, or the intensity of all responses to novel stimuli. So for example, an emotional reactivity test in dogs that involves scoring their reactions to several distinct novel or startling stimuli found that lower levels of emotional reactivity were predictive of detection dog success as early as 3 months of age. Therefore, it is reasonable to expect that executive functions, which are needed to perform goal-directed versus automatic reactions, may be related to emotional reactivity in these assessments. However, despite this apparent link, research on this relationship between executive functions and emotional reactivity is surprisingly lacking. So moving into the methods, the first task that I used was the spatial discounting test to assess inhibitory control, which started with a preference test to determine dogs' high and low value rewards. The dogs were given an option between a ball and a treat, and if the dog chose one of the rewards on 9 out of 12 consecutive trials, that reward was deemed their high and the other their low-value reward throughout testing. Now, out of the 42 dogs tested, 23 preferred the ball, 16 preferred the treat, and 3 did not have a preference in the 24 trials. Now, following the preference test, dogs completed the SDT. So let's say that a dog's preference was the ball. To start, the ball was moved to level 1, 25 centimeters behind the preference test location. Now, if the dog chose the ball, it was moved to level 2, or 25 centimeters behind level 1. And the task continued in this manner until either the dog made it to level 36, or they chose their low-value reward, in this case the treat, on 4 consecutive trials, at which point the test ended. The primary dependent measures to assess inhibitory control included both first switch, which was the level of the high-value reward when the dog chose the low-value reward for the first time, as well as maximum distance traveled, which was the level of the high-value reward when the dog chose the low-value reward 4 times consecutively. Next, the dogs completed 2 versions of the visible displacement task to assess both sustained attention and working memory respectively. Now, in the typical VDT, an experimenter holds up a reward, calls the animal's name, and hides the reward in one of several positions, in this case 3. Then a varying delay occurs in which the animal remains at the opening in view of the stimulus positions, and following the delay is released to choose a position. The issue is that the animal can use non-mnemonic strategies, such as sustaining attention or orienting in the direction of the correct stimulus position, to be successful on this task without relying on working memory resources. Therefore, in this study, we compared dogs' performance on 2 conditions to determine dogs' use of sustained attention and spatial working memory abilities. So this is a view of what our apparatus looked like. Each condition had a warm-up criteria of 5 out of 6 correct trials that matched the experimental conditions. In the regular study condition, that was a typical VDT that consisted of 12 trials with counterbalance positions and had delays of 1, 30, 60, and 90 seconds. And then in the non-mnemonic control condition, it was conducted very similar, except with the added control of moving the dog to the holding area during the delays. This prevented the dog from using sustained attention or other non-mnemonic strategies during the delay period. The dependent measures for this task were trials to warm-up criteria in both conditions, as well as overall percent correct in delay testing of both conditions. As I said earlier, the second part of this study included gathering suitability measures on the dogs. First, dogs' primary trainers filled out a detection dog performance survey in which dogs were rated on the level to which they displayed certain characteristics. These were on a 5-point Likert type scale from extremely low to extremely high. And a mean overall suitability score was calculated for each dog, such that higher scores represented more desirable detection performance characteristics. It's important to note that trainers were required to work with the dog for a minimum of 1 month prior to filling out the survey. Second, an emotional reactivity test was conducted in each dog, in which they encountered 5 distinct, novel, and surprising stimuli. Reactions to and recovery from each stimulus was coded using validated guidelines for working dogs, again on a Likert type scale from 1 being severe concern or fear reaction to 5 being no startle response. Now, following completion of this test, the scores were aggregated to create a final ERT score, such that higher scores represented lower emotional reactivity behavior or higher environmental soundness. So moving into the results, starting with the SDT, on average, dogs had a first switch level of about 13 and a maximum distance traveled level of about 22. There were no effects of strength of preference from the preference test, high value reward type, age, or sex on either first switch or maximum distance traveled. And within the VDT, starting with the regular study condition, dogs took about 8 trials to meet the warm-up criteria and performed at a level of about 78% correct on delay testing. And within the non-mnemonic control condition, dogs took about 11 trials to meet warm-up criteria and performed at about 67% correct on delay testing. Within the VDT, there was a significant effect of age, such that older dogs outperformed younger dogs on delay testing in both conditions. However, there was no effect of sex. In terms of Goal 1, our cross-task correlation did show a significant negative correlation between the number of trials to warm-up criteria on the non-mnemonic control condition of the VDT and first switch level on the SDT. I also found significant relationships between task performance and ERT score. So first, I found a positive relationship between first switch level of the SDT and ERT score. And second, I found a negative relationship between number of trials to warm-up criteria, again in the non-mnemonic control condition of the VDT, and ERT score. Taken together, these results suggest that the SDT is capturing a mechanism that is partially separate from general reward motivation and persistence. In addition, I found that an increase in inhibitory control related to faster acquisition of a working memory task. Now, this could be due to improved utilization of working memory resources, rule learning, or possibly attention. I also found that performance on neither task related to the domain of performance in detection dogs, based on the lack of correlations between the tasks and the handler survey. However, I found that an increase in inhibitory control, as well as faster acquisition of a working memory task, related to better environmental soundness with the ERT. So this is the first evidence of a relationship between inhibitory control and performance on the controlled version of the VDT, which is suggested to measure a purer working memory process than the typical version. This finding, combined with the lack of correlations between the SDT and the regular study condition of the VDT, supports the idea that these tasks are truly measuring executive function processes. Now, this is also the first evidence of a relationship between inhibitory control as well as working memory and environmental soundness in detection dogs. These findings support previous work that suggested this relationship in guide dogs, as well as the importance of inhibitory control and working memory in the ability to regulate emotions. Future work should assess executive functions in early development, as this information, combined with standard working dog assessments such as the ERT, could provide a multifaceted approach at predicting detection suitability and eventual success. I just want to take a quick minute to acknowledge my lab members who made this work possible, as well as all of the lovely dogs that I had the pleasure of working with. Thank you all for listening, and please reach out if you have any questions.